Right, this is the second attempt of doing this question because, things happens and my computer freezes and stuff. So here's hoping for the best. If you're gonna do that weird thing of going to the, apparently it's not doing that this time. Why? Never mind. I'm gonna start. So question 3, you need to draw a fully labeled diagram and you need to show the arrangement of 4 hydrogen H2O molecules around each other. We need structural formulas, which mean that you don't need to show the lone pairs of electrons, and you also need to show the strongest intermolecular forces present. So before I start drawing, I'm gonna just quickly work out the shape and the type of intermolecular forces present between water molecules. So water has one O and 2H, and then you have a lone pairs, 2 lone pairs, 1 lone pair up here and 1 down here. Okay, so that means that in order to arrange all the lone pairs and bonding pairs of electrons around the oxygen atom, the molecule needs to take a V shape. So if you count also the 2 lone pairs of electrons, then the shape is tetrahedral. Without the lone pairs of electrons, it's V-shaped. In terms of the intermolecular forces present, the strongest one will be hydrogen bond, because this is one of the 3 cases when hydrogen bonds will be formed. Okay, so now that we know that, obviously this is a polar molecule with the negative dipole being the oxygen and the positive dipole being the hydrogen atoms. So I'm going to start by drawing 4 H2O. Now you don't have to be too concerned about how V-shaped your H2O should be. It is supposed to be around 109, I think 120 degree is what it's supposed to be, but I'm not gonna measure your actual angle. As long as it looks decent enough, it's okay. All right, so I'm gonna do another one here, and I'm gonna label the dipoles as I go. Okay, and then you have one here. So that's minus, that's plus, and maybe we have another one, and then we have H, so that's minus, that's plus, that's plus. Okay, so I have the positive and the negative dipoles already. I'm going to do a little bit of key here. So this is positive dipole. And this is negative dipole. Now I also need to label the intermolecular forces, and you want to make sure that you don't use solid lines when you label intermolecular forces. You don't need to show every hydrogen bond that can be formed, but you need to have at least a few between the positive dipole of one molecule and the negative dipole of another molecule. So I'm going to do something like this and like this. Now I do want to point out, for example, if I get to here and if I just erase this a little bit, if I want to, why does this thing keep doing this? So once again, I haven't figured out what happened there. If I say, for example, want to show 1 hydrogen bonds between this hydrogen and this oxygen, this is actually incorrect because the hydrogen can only form 1 hydrogen bond. So each hydrogen atom can only form 1 bond. So you do need another hydrogen atom to form the hydrogen bond with this oxygen. You don't need to show all of them, as I've just mentioned, just some. And you definitely want to label them hydrogen bond. Okay, so this is what it's supposed to look like. So for 2 marks, make sure that you have, for 2 marks, I need to have the 4 molecules. I need to label the dipoles. dipole's label, you need to also show and label hydrogen bond. So that's what you need to do for 2 marks. You can think of the first 2 things to be part of the first mark. So it's when you get the molecule set up, and the second mark has to do with your intermolecular forces. That's part A. Moving on to part B, you need to refer to the answer from part A to explain why at room temperature H2O is a liquid, why O2 and H2 are gases. All right. So in order to do that, we are going to need to refer to the intermolecular forces between these molecules. So whenever the question talks about or asks about things like states, then you really want to think about the intermolecular forces present. Now this is also a 3 marker. So I think the first mark is for referring to part A and identify that based on part A, I'm just going to refer to part A a little bit, or according to part A or something of that nature, H2O is a polar molecule which has I'm just going to go H2O is polar and has hydrogen bond between its molecule. So that's the first mark. Now the second thing is for saying that O2 and H2 are both gases. Actually, I don't know why I said gases. Are both non-polar and have dispersion forces. I think it's very obvious that it is they are non-polar because you don't have any difference in electronegativity at all between O2, so between the 2 oxygen atoms, and between the 2 hydrogen atoms. Anyway, you have dispersion forces between the molecules. So that will be the first 2 marks. You do, however, need to make a direct comparison between the strengths of these intermolecular forces to get the 3rd mark. So I would go ahead and say something like hydrogen bond is stronger than dispersion forces and would require more energy to break. It's good to link it back to energy because the amount of energy required to break the bonds will actually influence the state at room temperature. So at room temperature, you have a certain amount of kinetic energy in the particles. If the energy is required to break these intermolecular forces is higher than that, then obviously not all of it's going to break and you have a different state. So it requires more energy to break. Hence, H2O is liquid, while O2 and H2 are gases. Okay, very good. That's it.